now. Our topic for today is Markerless tracking using augmented reality. And these are the contents that I will be briefing you for today. We will start with what is mean by augmented reality, and then what are the various types are there, what exactly markerless represents, and then what is the difference between marker and markerless AR, and how it works, what are the applications are there using markerless AR, what is mean by location based AR and where it can be helpful, what are the advantages and disadvantages are there in these technologies, and what are the present applications that we are using without knowing it. It falls under AR category. And we will also see what are the software development kits are available to develop an application using AR technology, and which are the industries are more into AR. And finally, if I learn AR, what will be my future, whether I have to choose AR as a technology for my career or not. All these things we will be discussing in today's session. To start with, what is mean by AR, as I was telling you, we are going to bring in imaginary things into our real world. For example, we so far we will be saying animations, cartoons and all, right? You would have seen animated movies, 3D movies, all those things. Now what is the difference between the animation and then this AR is, in animation we will make certain cartoonistic images to talk and to walk, and then to mimic whatever we say. All these things it will be doing. The same cartoon image, if it is there in my home or if it sits next to me, how it will be, that realistic feel you can get using augmented reality or virtual reality. Even if somebody who is close to your heart have passed away, and if you want to make them to come and speak with you or to spend some time with you, then we can create that character and we can visualize them. We can give voice to them, and we can add whatever we are feeling to have with them. Like voice you can add some images, and you can make that image to move around or to dance, whatever you wish to do with that imaginary character. You can do that, and you can feel their presence in a realistic way next to you. That is what augmented reality and virtual reality is all about. We are going to augment video or sounds and then the images to an imaginary thing within a realistic world. That is what entirely about it, how we can achieve it. So what is the base for it? Here we are going to use computer vision technique with algorithms to make that imaginary character to work in a real world. Okay. And you can see in that one image will be there in this screen. What it is, if you look at the background of it, it is just a room. In a room, if I want to keep some of the sofa, some furnitures, before purchasing it, whether it will suit for that room, whether that color will suit or not, whether that particular size of the furniture will be compact to my room, or I have to go for a bigger one, a smaller one. All these decisions you can easily take by having AR technique. If not, what will happen? You will spend money for it. You will purchase a sofa or any dining table. You will place it in the room. After purchasing, after spending money, if you feel discomfort with that, you cannot able to throw it, and then the money that you have spent will get wasted. And whenever you see that, you will feel that discomfortness. We have taken wrong decision. We should have purchased a bit bigger one or a bit smaller one. Then the color also doesn't match for the background. We would have chosen some other color. All these things will be there in your mind whenever you see that image or you see that product in your home. But with this AR technique, what we can do, just you can open your camera in the living room or wherever you want that object, and all those objects will be there in your mobile device itself. You can drag and drop, which will be seen to you what it will be if you have kept that product over there. As you are noticing in that image, there is a sofa. You want to place it in that room. You can clearly see in your mobile camera itself, if I keep a sofa in that living room of that particular size, of that particular color, how it is looking. If you feel it is good and then comfort, then you can purchase it, wherein your money will not be wasted and you will get a real satisfaction after purchasing the product. Because already you have seen in your mobile device, you have augmented that image, and you have seen how it will look like when you keep that product in your living room. If you are satisfied, you can go for that, otherwise you can ignore it. And many of the e-commerce applications are now with this kind of applications. Even you can see in Lenskart and in many of the online shopping, they are offering you a 3D augmented technique where you can wear and see, and you can change the colors and then the shapes, whatever you wish. And once you feel comfort with the product, then you can buy, which will give you a more satisfaction, uh, like not like earlier. After purchasing, you will feel like, no, this we have taken a wrong decision, we should have gone for this, that, all those won't be there. That's why many of the software industries and then many of the customer centric industries are more onto augmented reality, wherein they can satisfy their customers before choosing the product. You can now itself dream of what are the companies that are looking for AR developers. So first it starts with gaming, because all imaginary things have to be projected in your live screen so that people will be happy, and many of the customers you can interact towards your game. And second thing is, wherever we have trading and commerce platform where you want to sell your goods and to make your customers more satisfied, then preferably the option is for AR and VR developers. So this is what AR is all about. We are going to superimpose an imaginary component in a realistic world, which gives you more of comfort. Whatever the imaginations you have, you can bring into the real world to experience it. I hope it is very clear for you. Moving on to the next one. Yeah, here comes types of augmented. Yeah, types of augmented reality. Now we will be having a question, right? Okay, I have purchased a product, whether it is only for the product or what exactly it is, and how I can superimpose the image. If I want to fix that product in my room, then what type of technology I have to use? Or is it applicable for all? For example, in many kinds of mechanical engineering and then medical field and all, they want to know about the machines, how it really works. If we read it theoretically, then it won't give much of the knowledge. Wherein if we give a 3D way of reading to know much about the machine, how it really works and what are the principles they have applied, if the principles get changed, then how the machine works. If you want to make it more realistic, then whether AR will work, all those questions will be there. For that, the answers are these things. Like 3 types of AR techniques are there. Initially it started with marker augmented reality, and now presently many of the industries are moving to markerless augmented reality. And we do also have location based augmented reality. The difference here is, if I take marker augmented reality, you can see in this slide a picture is there. So one particular page which consists of 3 images, right? You can see the skull and then brain part, and one more internal brain is there. If I place my device and if I locate my device exactly to one particular image where I have kept user viewpoint, only this is required for me, which should be projected in 3D, or which for that I need some working principles to be augmented over it. Like sound you can augment, or you can add some 3D effects to it. If you are fixing up a user viewpoint, then that is called marker based augmented reality. So I have to decide my marker space over that image. This is a particular location and only this is going to be my user viewpoint. If I fix that, then it comes under marker augmented reality. Assume that I'm not going to fix any user viewpoint, because I'm clueless. where exactly I'm going to place my carpet in my home, or where exactly I'm going to place my imaginary character in my home. Anywhere I can place, but it depends on my choice. Today I will place here, tomorrow I can place in the left corner. So where user viewpoint is not exactly defined, then we can go for markerless augmented reality. So marker can be anything. Using anything, you can fix up a user viewpoint. Once you fix up user viewpoint, that falls under marker. If I don't have any user viewpoint, exact viewpoint, if it is not there, then that falls under markerless augmented reality. So third thing, location based. Location based is also a subcategory of markerless viewpoint, markerless AR, but wherein here it will clearly tell you on the go, like you are traveling, and if you want to know what that building is, or this path takes me to where, then you can just open your camera and then GPS, it will project you on the floor itself, on the sky, or on the building. Like this is the building, then next to that this particular street will come. If you take right, this street will come. Like that you can see imaginary letterings at the path in front of you. So it is totally to take you to the maps. In map, whatever we are seeing is in your mobile screen. It will tell you the location. If the same thing happens in front of your eyes, if somebody tells you this, if you go right, it is street number 1 of this particular place. If you take 2-3 streets ahead, and this is your destination where you can find some malls and then restaurants, all those things, then how beautiful it will be, right? That a real world experience you will get from the maps. So those things comes under location based AR, which is also a part of markerless AR. Okay, so these are the 3 types of AR techniques that are available. And coming to marker, so for any doubts, is it okay or am I going fast? Anyone, please respond me.
Okay, madam, you can continue.
Yeah, thank you, ma'am. Because I don't know, again, there is a network interruption. That's why I want somebody to interact with me in the mid. So here comes markerless augmented reality. So we are not going to define any user viewpoint, but if I want to do some activity which is imagination, and if I want to bring it to a real world, then we can go for markerless. As of now, there are many organizations that offers and then works on AR. In that, very familiar and then more popular is Apple's AR AR kit, and then Google's AR Core SDKs. These are the one which focus more on augmented reality, and then many of the gaming applications using markerless augmented reality. And then the image in the screen clearly tells you this is for cancer treatment, how markerless AR helps for better tumor detection. First thing is like if you look at this first one, first method is standard treatment, wherein it is a static beam. Whatever the tumors they want to detect, they will place the device, and that beam will be static. You cannot project it however you want, or you cannot divert it however you want. It will be a large beam and a static one, and they will be fixing up with the patient body where cancer is there. Then what they will do, they will try to hit that point to destroy the cancer cell. Assume that if a patient have been moved a bit, or because of breathe or other circumstances, if it gets dislocated, then they cannot do anything. Cancer cell will get missed, wherein that beam will affect the normal cells, which is healthy. Then what will happen? That patient will remain with tumor, wherein a healthy cell will get destroyed. But if we use this markerless tracking, then this beam is adjustable, and you can locate it wherever you want, and you can keep tracking. You can visibly see whether that beam is on the tumor cell or not. If a patient is moving, again you can relocate the beam before injecting it, and before treating the patient, you can locate it wherever you want, so that precise location will be set and you can hit the cancer cell. So the chances of hitting a healthy cell will be very less when compared with traditional treatments. So in medical field also, it is of strengthening now. Even medical students, textbooks, and then the way they learn everything are into AR and VR techniques. So if you pick this as your career, definitely you will get a good scope for longer time. So this is what in current and then standard treatment you can see. It is suboptimal, and also collateral radiation toxicity will be more, wherein if it has been replaced with AR, then optimal local control will be located exactly where it is needed. With the help of that, you can reduce the radiation toxicity, which won't affect the healthy cell. And as I was telling you, if it is marker based, then you have to fix up user viewpoint as they have did it in this image. Like 3 images are there. Exactly, you have to fix up which image you want to superimpose or you want to augment anything. And earlier days, everything was marker based, but now they are moving to markerless. So this is the difference between markerless and then marker based AR technique. First image is markerless, wherein a person opens his camera on the floor. He can just fix up whatever the products he want to put on that floor. So here he wants to put some mat carpet for his floor. So he's just picking up a carpet and placing over there. He didn't fix any user viewpoint there. Which particular product I have to view, that he didn't decide. You can see very clearly. He has just opened the camera and he can drag and drop the products so that he can visualize, if I place that particular carpet on my floor, how it looks like. But look at the second image, that is marker based, where he exactly keeps his camera position on that particular image to visualize it in 3D. And next to that, that sofa is there, right? That is also markerless. So if you are not defining any user viewpoint, this particular image, this particular place, then that falls under markerless. If you are defining like this, he has opened a textbook and he has kept over that particular image to view it in a 3D, then that comes under marker based, because he has defined user viewpoint. That user viewpoint can be anything. Whatever you are considering as a user viewpoint, that will be termed as a marker. And here comes a more common question. How does this markerless augmented reality work? For that, first let us understand what is augmented reality. So first thing will be your mobile or computer generated data. If I want some imagination, I will be having some imagination like cartoon character. Let us take Talking Tom. Okay. If I want the Talking Tom immediately next to me, that computer generated Talking Tom is your augment. Okay, because that is my imagination, which is familiar for you. That's why I've taken that one. If you have any other imagination like Pokemon Go or whatever the character, you can just imagine it. That how you will be creating, you will be creating it through your computer, right? That computer or mobile generated data is your augment. Where I'm going to augment it? Next to me, that is my real world, physical world. That if you connect these two together, like my physical world where I'm presently living, I'm going to connect my imagination, that is augment, which gives you an augment reality. So once you implement this, I can see the Talking Tom next to me. Okay, so how it works? It works in this way only. Like you will be picking a real world scene, like this is my living room. I will pick this and I will pick one virtual object, and once I connect these two together, then I can see it using my visual eyes, like how it is there now in this image. Like a shark enters you, and a shark or blue whale immediately is there in front of you. How it will be feel for you, how the feel for you it will be if an imaginary character is in front of you. So that type of creativity you can bring in using AR. That is what here also you will be having a physical or real world through your camera or GPS. You will be connecting it to your mobile generated imaginary character. Together gives you an augmented reality. This is a simple example for this. You have written on a paper like SM Lee's design, and your design actually what it is like your imagination character will be there, right? That you have drawn or generated thoughts. Okay. Once you augment, once you augment this, then you can see the output here, right? This particular image have come on the paper, whatever you have written on SM Lee's design. Over that sheet, you can see this realistically. You can rotate it, you can make it to run if you want to make it to fly, a 360-degree angle view if you want. All these you can do. Then it will be like a realistic. Whatever you designed on your computer, you can see it using your eyes. Okay. That is what. And now we can see some of the things about location based AR technique. So here it is. The more awaited, like Pokemon Go is a more popular game. Everybody would have gone through it. So all those are through location based AR, where you can visualize. If I'm going on a road, if I want to know what is in the next street, then I can visualize it in front of my eyes, need not to go through my Google map. Just I can open my camera. If I project it on the road, I can able to see what is the street and what will be the next street. So it will be like more or less a realistic approach. Somebody is there to guide you where you have come from and where you want to go, what will be there in the next street, what is there more popular in this street. All these will be flashed onto your eyes, as you were seeing in this particular image. Like all those visuals they can able to see. They are not using their mobile device here. They didn't open their Google Maps. Just in front of their eyes itself it will come. If I pick location based AR, then it will come in a visual only, like what is there and what is the most famous place that is available in that particular location, and what is a famous mall available near to me. All these will be there to guide you. See, he has just opened his mobile. He has opened his camera. He can able to see shopping center with these many ratings, and coffee shop is there and fashion shop is there. All these information will be just flashing onto your eyes. So this is how location based AR will help to make imagination into a realistic world. Now comes what are the advantages and disadvantages. The main advantages is you need not to have a marker, because you many of the times we may not be knowing what will be our user viewpoint. Exactly, we cannot choose except for the studies or for the textbooks or for the reference materials. For rest of the cases we cannot our marker. This markerless AR will be an added advantage for you to capture entire physical world without defining any of the marker, and it will increase the average range of motion. If you are fixing up user viewpoint, then only that location you can able to capture, wherein using this you can get wide area of coverage and you can handle it using your mobile device itself. You need not to have a special software or anything for this, and you will get a real experience of having imaginary things into your real world. And whatever your context or whatever it is there in your mind, you can try to bring into a real world, which will help you in many of the applications like medical field, where more specific things are required. Even it can be for vision treatment or cancer or in many kind of diseases. It will be really helpful, where you can visualize what happens internally and you can treat that particular part exactly through AR technique. And what are the disadvantages? Again, this requires a textured surface. If I'm thinking of any forest area or if you are thinking to implement it in any uneven surface, then it will be a challenging, because it is more of like placing an object to a real world, right? Assume that there is a dense forest, and if you are thinking to place it on the ground of a dense forest, then it will be really challenging. We don't know where is the surface. It will be covered with complete trees, where you cannot exactly identify what is your surface, and even if you place your object also, it won't be visible to you. So that's why that is one of the thing, where you need a textured surface, or it should be dependent on some flat surface or even surface. If it is there, then you can bring in easily. For example, if I'm planning to set up a lawn or garden in front of my home, yes, that is easily made available using AR. If the same thing, if you are thinking in a dense forest, you want to put some imaginary animal into it, then you cannot project it. If it is a flat surface, or if you are entering into the forest and taking image of the surface, then it's fine, you can fix up some imaginary animal to it. But I'm taking aerial view of a forest where it will be covered with tall trees, and if you are trying to put some imaginary character to it, then just imagine how it will be. It will be hanging on the tree, you cannot see the surface clearly. So that is one of the constraint we have, where it will increase the complexity. If you are going for some uneven surface or any dense forest kind of, then there will be a more challenging role for you to place your imaginary object exactly where you want. And next thing is, as we all know, all these modern technologies require GPU, and then similar to supercomputers, to add your data and then to work with your data. For all these, you require a lot of power. That capability devices will help you to develop those applications. And we should need a wearable device to see all those whatever happens. As of now, you would have gone through the glasses, 3D glasses, or the goggles, which helps you to visualize that imaginary thing. We cannot see it through our naked eyes, wherein we need some headsets or the glasses to visualize it. That we have to accept. And now, apart from gaming industries, many other smaller industries also slowly moving on to AR. As I was telling you, like e-commerce platform to wear your lens, or if you are trying to purchase one watch, if you want to know whether it suits you or not, all those things you can test drive using AR technique itself. That gives you more satisfaction before you spend money for any of the product. And many of the academic industries, and then education field, they are moving to AR technique. The reason is, why they are moving, as I was telling you, if any machine is there, if you want to learn working of that machine, then it will be more simple and easier. If you are going with AR, it will teach you how really a machine works. And then if you are adding a RPM to it, how the machine will react. If you are reducing it, how the machine will react. All these things you can visualize and see, which will increase the concentration of a student, and it will help a student to learn more, to gain more knowledge, as if he is working practically. Okay. And these are the certain places where they are using markerless AR. You can see in these images, he wants to buy one ring, but before purchasing, he's trying to insert in his finger to know how it looks like. Once he feels satisfied, then he can purchase. Otherwise, he need not to spend money. And whenever he see that product, he will be keep thinking of it. We have wasted our money, that doesn't suit us. All those won't be there. All those confusions we can avoid. And also, if you want to change a product, you can do that. You can do the change in product, and you can, and if you want to rotate it in 360 degree, you can rotate it. If a ring speaks with me, how it looks like, that audio also you can add. And if you want to bring that ring to tell you something, or if you're presenting to somebody else, if you want to convey some message to that, all those you can add. That superimposition is what we are calling it as augmentation. Okay. And in education field, if I want to learn how heart functions, then you can just project that heart. It will explain you and it will show you clearly how heart functions. So that is how it is more helpful in education field also. And these are the top industries which functions on markerless AR. As we know, Google and then Apple are in leading. And apart from that, there are many other organizations which focus on markerless AR, accent MXT tracking, which is a location, and then
Participants kindly mute
Apple's
your mic.
ARK.
Ma'am, proceed now.
Okay,
Proceed now.
Thank you, ma'am. So in Apple's ARC kit, they are providing this feature for all their users, wherein you can have a better gaming. For example, if I want to like workstation, I cannot able to purchase, and if I want some realistic experience of any of the games, then all these features are built in. You can go for that workstation, wherein you will be wearing your goggle and similar to playing on the ground. You will be playing like that opponent will be playing with you, he will be communicating with you. You will get a real exposure of game. Okay. And even Google is working motion tracking and understanding the environment better, climatic condition change, all these they are doing light estimation, then interacting with the users through imaginary animations and then oriented points. All these are in work, and many research is also still happening. And Maxent is doing wonderful applications, especially when it comes to location based. Even I have given in the end many of the reference sites. You can go for that and you can see what are the products they have developed and who are the clients for these industries. You will get really a surprising components, and all those are more interesting to know, and it will change the world. Like many of the people who are in depression, and if they feel like they are left alone in all those circumstances, this will give them a companion, it will interact with them and it will motivate them. So wherever we are speaking about advancement in technology, definitely disadvantages also will be there, which will apart is from togetherness. Like they won't spend time with their relatives like earlier, the traditional way of sitting together playing in a physical world. All those will be missed. But this is an added advantage where we can think of to make betterment for the society, for certain kids who are depressed and who are physically challenged and who needs some support to come out from mental retardedness. In all these circumstances, this technology will be really helpful. So these are the industries, the chart that tells you very clearly. Students, don't annotate anything. Okay, in this image, you can see education industry is spending $7 million for AR technology in every year. Then real estate is investing $2.6 billion, and engineering field they are investing $4.7 billion. Live events, then military and healthcare, you can see huge number of investments are happening from healthcare, and then gaming. Closer to 12 billion for video games, and then improvements in gaming technologies, because many of the people are addicted to it, that to present Zen generation. They are more addicted to video games. To attract them even more, they are investing a lot in AR to provide them a real experience of game. Then in healthcare, they are investing 5.1 billion to devise a machine which will easily identify internal organs and then to cure the diseases. Okay. So for interior design, in retail, Amazon is using, and then in interior design, IKEA is using this AR technology. Gaming, Microsoft HoloLens is an famous example for gaming, and for advertising, like 3D advertisements, or if you want to advertise in more realistic way, then we can go for AR technology to prepare the advertisement, to market it. And in education, Elements 4D, and then Anatomy 4D, that is for medical students to learn more about the human body, its functions, all those things. In healthcare, Overlay 3D models, that gives you to understand about what virus is and how it infects our human body, and what are the things it will create in our body, how we have to protect it from all those diseases. And in tourism, mainly location based AR, like online travel website which will help you to navigate from one place to another place and give more information about those places. And then more important aspect of that place that you visit, all these things you can get to know more realistic way. And finally, entertainment, like if you want some live concert to happen in your room, wherein singers will be there in your room to sing for you, and then some activity if you want to do, all those sporting events you can do with the help of AR technique in entertainment. So these are the places where AR is in place, and it is doing very well. And this is the future of Markerless augmented reality, where it is going to grow in an enormous way where we didn't even dream of. And it will give you, it will take its place similar to AI. It will take its place. It will occupy in all the stream, not only like gaming and then healthcare. It will slowly occupy in all the places, and it is going to be part of our technology. And enhanced visualization will be there. And if you want to bring in some of the new components for teaching, and then if we want to bring some components for learning, and to get some practical knowledge out of it, if you want to work on a teamwork or any projects or anything which is virtually available, all these are possible with the help of Markerless augmented reality. So in all these domains we can see it will take its place. So that's why it is in trend now. And the last slide of the day, references. These are the references. I will share the slide with organizers. You can get from them. You can go through the sites wherein you will get more interesting information about AR technique. And you can also download the softwares. Open source softwares are available. Free licensings are there. You can download it, and you can just start with placing a lawn or grass for certain square feet, and how it will be if you play, you can do. And then you can create one imaginary character, bring into your lawn. All these you can slowly do. I will try to arrange one workshop if any chance is there, then I can teach you some of the practical how to implement it. But these references will give you a clear idea how AR works, and it is very easy. No coding is required. Even if you start from the basic, you can learn it very fastly. Okay, all those components will be readily available. Packages are there, Python packages. You can drag, drop whatever you want, you can do it. These are about today's session. Now it's open for queries and then clarifications. Any doubts or any clarifications? It's open to the audience now.
Madam, the session is very fantastic, madam. I really enjoyed this.
Thank you.
And the last time, one of our batch did the project in this AR, and
Okay,
they struggled
that's
something
really
to
good.
implement, madam. Is there any software suitable for students to do projects?
Ma'am, shall I share it with you after this? I have certain links. All those I will share it with you. That will help them, ma'am.
Yeah, sure, madam. Thank you.
Yes, ma'am.
I really enjoyed this session, ma'am. You are really fantastic. You did well.
Thank you.
Thank you.
Thank you. It's my pleasure. Yeah. Dear students, if you have any queries or doubts, you can post it in the chat box. What makes AR different from VR? Here in VR, that is virtual reality, like watching a movie, a 3D movie, all those also comes under VR. But in AR, we can superimpose, like we can augment some image, or if you want to give some sound effect, like as I was telling you in the mid of my presentation, if somebody closer to you have passed away, if you want to bring them in, and if you want to make them to speak with you, to respond for you, all those impositions you can give, like you can give emotion to that, you can add some text to it, volume to it, all those you can do. That's the difference between VR and AR. Yeah. Thank you, Revati ma'am. Any other doubts?
Students, do you have any doubt here?
Thank you, Shenba ma'am.
Some student Silambaran sent a message. Doubt, ma'am. He sent doubt, ma'am. I think he want to ask doubt directly. Silambaran, are you there?
Yes, Silambaran, what's your doubt? Yes, sent one more message. Thanks for providing good knowledge, ma'am. Thank you, Silambaran. Dear students, feedback form is there in your chat box. You can fill it up.
Anybody is having any doubt here, Pa? You can ask now.
Yes, Silambaran, you have raised your hand also. Speak out.
Unmute your mic and speak, Pa.
What kind of problem can AR solve? AR won't solve any problem. We have to make AR work for us. If you are having any for e-commerce application, you can add a module wherein customers can able to fix up their products according to their wish, and they can decide whether the product suits for them or not. So that is one place where you can implement AR. And next thing is, as I was telling you, for interior design, as civil engineers will be there, they will tell you can have a lawn of this square feet, and you can place this here, you can place that there, like that. Architectures will give some suggestions to them, but you can create one application wherein the customer or the people who wish to go for that interior design person, they can visually see if my lawn is of this square feet, how it looks like for my home. And if I place some of 2-3 plants in front of my home, how it really looks like, that they can visualize it. If they feel comfortable, they can go for it, otherwise they need not to go. So these are certain problems you can think of to develop an application using AR. So AR directly won't solve our problem. We have to use AR to solve problem. Srikant, is it okay? Yes, welcome. Due to time constraint, I have just rushed up.